All right, again, to kind of go through this quickly, we had a diagram that looked like this. How many ways to travel from 1 to 4? Y'all said three, because we can go 1, 3, 4, 1, 2, 4, and 1, 3, 2, 4. You cannot go 1, 2, 3, 4 due to the fact that there's no arrows. Um, we talked about what bus routes don't make sense is that we can't get from 1 to 4. If you leave 1, you can't get back, and once you get to 4, you can't leave 4. So that's some of the bus routes that didn't make sense. I guess you could walk back. Part C, we then got a new diagram with arrows on them, and there's only one reasonable way to get from city 4 to city 1 by simply going from 4, then to 2, then to 3, then to 1. And then I just asked y'all this question right here. We now have three rival, actually, that's purple, right? So there's four rival bus routes, looks like, for the different colors, right? Was that blue and purple the same color? And then it's the one, right? It looks like the rest of them are blue. Okay, okay. It looks like different colors, but my vision's going off. Like when I look at it, they look like different colors, and then when I look at it again, I'm like, well, maybe they're the same color. I think they're the same color. No, there's a green and a red. And then this is probably so no blue. Okay. Yeah. I can see purple here, but when I look at this screen, I see blue. Oh well. I think I am slightly colorblind when it comes to purple and blue because I argue with people all the time going, that's blue, and they're like, that's purple. And I'm like, no. So you can ask former students on that one. All right, so in part A there, it said, what might the loop at City 1 represent? So when we're looking back at this, any ideas of what that little loop thing would make? Mhm.
I just shot out.
Okay. 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 I like that. What do you got? A turnaround? Any others? And back in town or something? Yeah. Okay. I got you. So basically, what this route one right here, this loop, just means that you can leave one and get back to one. So maybe there's just somewhere in city one that you want to travel to or something. So you just leave from one port to the next. You ever been to Houston? The metro train? So like one end of the town to the other side of the town, right? It's just a big gigantic circle, or a loop. So that's kind of what that little loop could represent. So basically, what you can say is a route to go from city 1 to city 1, basically. Right? Maybe you just want to look at your town that you live in. All right, part B then says, how many ways can you travel from city 1 to city 4 if you want to stop in city 2 and make no other stops? So we want to go again from 1 to 4, but we want to stop at city 2. How many ways are there? Think about it before you say it out loud. All right, do we all have an idea? How many routes did we come up with? Very good. Okay, can you tell me how you came up with 6? That's exactly right. If I'm at city 1 and I want to get to city 4 and there's a city 2 I want to stop at, I want to avoid city 3. So I can take the red bus route to 2, and then from there I can then take purple, or I can take green. So there's 2 right there. I can then take purple and then take purple and green. So that's 2 more. So that's 4. And then I have green and I can take purple or green. So there's 2 more. So there's 6 different ways. An alternative way to look at this is what's that theorem? I think it's was it probability of large numbers? We just learned it last semester in statistics. I forget now, but basically if you have multiple options, you can multiply all of your options and that will tell you how many total outcomes you can have. So to get from 1 to 2, I have 3 different ways to get there. To get from 2 to 1, I have 2 different ways to get there. So if I have 3 options here and 2 options here to find out how many total options I have, I can simply just say 3 times 2 and get 6 different pathways rather than having to. Right now, it wasn't too bad, right, to count them up just to 6. But think about if we had this was like a big New York City, right? Let's say there's 15 routes to get to New Jersey or whatever, and then 13 routes to get to the next thing. That's a lot of trying to calculate. It'd be super easy to just go 15 times 13 and get the answer that way. Any questions on how to find out how many total outcomes you can have? This is important because this will be coming up throughout the week. So we're good there? All right, so on that part B there are 6 different ways if you want to go from 1 to 4, but you want to stop on route 2. Part C says, how many possible ways are there to travel from 1 to 4 without repeating a city? Again, think about it. And then try to come up with an answer. Again, you're trying to go from 1 to 4, but you don't want to backtrack. So for instance, you want to go 1, 2, 3, back to 2, right? So think about that. All right, how many ways? 15 would be the answer. So let's think about this. I want to go from city 1 to city 4, no stops. Can I do that? No, I have no road to get from 1 to 4. So therefore, I'm going to put a 0 here. But that was an option that could have been there had I had a bus route. Now I want to go from 1 to 4, but I want to stop at 2. How many ways can I go from 1 to 4 with stopping at 2? 6. And we did this earlier. There were 3 ways, then 2 ways. So 3 times 2 would give me 6. Now I want to go from 1 to 4, but this time I want to stop at 3. How many ways to get from 1 to 3? Only 1. Notice that this does not have an arrow going to 3. So there's only 1 option there. And 3 to 4, there would be just 1 as well. So in total, how many ways do I have to get there? Still 1, right? Because 1 times 1 would still be 1, which again makes sense because I only have 1 option the whole way. This time I want to go from 1 to 4, but I want to stop at 2, then 3. So I have 3 here. How many ways can I get from 2 to 3? I can go there 2 ways, right? Someone sneezing? Oh. All right, so I can go from 3 to 2 to 1. So this time I would say 3 times 2 times 1, but that would still give me how many ways? Still 6. Now this time I want to go from 1 to 4, but this one time I want to stop at 3, then 2. So I have how many routes to 3? I still have 1, but how many routes do I have to 2? I now only have 1 option. And then from 2 to 4, I have, so this time I have 1 times 1 times 2, which gives me 2. All right, so then we just add them all up. So I got 6 plus 1 plus 6 plus 2, which gives me 15. All right. Questions on that? Does this make sense? Absolutely. Right now, we're just talking about multiple bus routes. I'm going to throw in some subways in there and all kinds of different things. But for now, I just need to make sure you understand the arrows and what they mean to go from one spot to the next spot. It's like learning how to read a key map. Anyone know how to read a key map? Yeah, one person. That depend on just Google. Key map is a big orange books that have maps in them to break it down by cities and locations where you're at. And depending on what county you're at too, they're like this thick. And just do like San Jacinto County, there'll probably be like 4 different of those. And it's just a big old map just cutting sheets. All right. Any questions then? Starting the semester off easy? We'll go easy-er. True. There is no I. All right, so there we go. So we got 15 ways to travel from 1 to 4 without repeating a city. So in this third challenge here, we're going to consider a direct route to be a route from one city to another without going through any other city. That makes perfect sense, right? It's just one spot to get there. Organize the number of direct routes from each city in the table shown below. The first row showing the direct routes between city 1 and the other cities is complete for you. So we're going to finish this. And basically, by doing this, we're going to form a matrix. Now, which figure are they wanting us to use? I'm going to assume figure 3. Let's see, is there a way? I think I'm going to do this. Yes, correct. All right, so you already have this built. I'm going to try to build it so I can use the map as well to help guide you. So this first one, this is your origin. So this is where you're going to start. So it goes city 1, city 2, city 3, city 4. This is where you'll end. This is your destination. City 1, city 2, city 3, city 4. They filled out the first part of the chart for you. Would it help me to put lines or would y'all understand? I'm going to use different colors. I'll use yellow. No, yellow can't be seen. We'll use green. All right, so then they gave you and they said this was 1, this was 3, this was 1, this is 0. Let's talk about where those come from. I start here, I end here. So I'm going to start at 1. Can I end at 1? Yes, 1 time because of that loop. Then I go from city 1 to city 3. How many ways to get from 1 to 3? Oh, I skipped 1. Sorry, I did. I skipped 2. To go from city 1 to city 2, how many routes to get there? There's 3. So that's where that 3 comes from. To get from 1 to 3, how many ways can I get there? Just 1. And to get from 1 to 4, a direct path, can I get from 1 to 4? No. So that's why it's a 0. We're going to do direct paths. We're not going to try to get in between. So with that said, how do I get from city? How many ways can I get from city 2 to city 1? 2 ways. Notice the arrows right here. All right. Before I continue, does everyone understand? I want to give you an opportunity to fill it out first, and then we'll check it. So go ahead and fill out the rest of that chart with that understanding, and then we'll make sure you're correct. No, direct paths only. So if you can't get, like, for instance, from 1 to 4, there's 0 paths there. All right, are you ready? Good. I'll give you some more time. All righty. So how many paths can I get from 2 to city 2? 0. I don't have any loops on city 2, so I can't get back to 2. How many ways to get from 2 to 3? 2. 2 to 4? 2 as well. 3 to 1? 2. 3 to 2? Just 1. There's only one arrow there. 3 to 3? 0. 3 to 4? 1. 4 to 1? 0. There's no direct pass there. 4 to 2? 4 to 3? 4 to 4? 0. Any questions? All right, so let's go ahead and move on to the exercises. We're going to use this box that we just created, and we're going to turn it into a matrix. So here we go. So I'll rewrite it for your reference. So I told you there'll be a connection back to what we left off with. So we're going to use the network diagram in figure 3 to represent the number of direct routes between the 4 cities as a matrix R. So they want us to call it R. And here we go. So I'm just going to rewrite it. So this will be 1, 3, 1, 0, 2, 0, 2, 2, 2, 1, 0, 1, 0, 2, 1, 0. So that's basically the box that we just filled out in the previous question. We just now wrote it as a matrix. Questions on that? Now we're going to do things to this. And it says, what is the value of R23? Do y'all remember? I think more in Algebra 2, I think I talked a little bit about it in this class. What does this mean? 2, 3 when you're talking about the element of the matrix. Yes. The columns of it, or did you say rows and columns? You would be correct. It is written as rows, comma, columns. So if I ask you what R23 is, that would mean I would need to go to, now I'll label this. This would be considered row 1. So these will be my rows. Row 2, row 3, row 4, and then these would be my columns. Row 1, row 2, row 3, row 4. So when I'm wanting to answer this question, I would go to row 2, column 3, and what's that answer? Correct. All right. But then it has that second question. What does row 2 to 3 mean? Or R2, 3. What does that number right there mean? It's not just a 2. It has a meaning. We just, 2 ways to what? Well, when you say 2 to 3, you mean what? Give it context. Remember, these are bus routes.
To get from point 2 to point 3.
When they were called cities. Gotcha, yes. You're right there on it. This represents 2 ways to get from city 2 to city 3. Right? And you can kind of see this right here. This first number is going to represent your first city. The second number is going to represent your destination, your end route. Right? We're good on that. So what's going to happen now is I might just throw a matrix at you, and then I might ask you, how many ways are there to get from city 2 to city 3? And you would need to pull that information from the matrix rather than having to make the matrix yourself. Yeah, I would give you this question exactly. I would be like, hey, what is this and what does it mean? You would say, all right, well, that means it's 2, and that means that's going from city 2 to city 3. Are we good with that? Not much math has happened, just a lot of reading and analyzing of diagrams, right? I hope you're not being sarcastic, and I hope you really do, because I really enjoy this topic. All right, here we go. So now what we're going to do is we're going to figure out what the value of row 2, column 3, 2, 3 is times row or the element of row 3, column 1 is, and what does that represent? So let's start off with that first. Let's start off with just simply asking ourselves, what is R2, 3? 2, right? We just did that. What is R3, 1? 2, right? So I go to the third row, first column, and it is a 2. This tells me to multiply these things. So 2 times 2 would be 4. You answered that first question. But now it's saying, what does that represent? Anyone got any ideas? Go ahead. Not 1 to 3. Huh? Not 2 to 3. Not 3 to 2. Not 3 to 1. What is it? No. 2 to 1. With a stop where? At 3. Notice the pattern here. I'm trying. I first found how many options I got from 2 to 3. So I got from city 2 to city 3. Now I'm at city 3, and I'm going to get to city 1. So this was my stopping city, but this is how many routes I got from city 2 to city 1, where city 3 is my, I don't know, rest stop or whatever it is, my stop. So this would mean 4 ways to get from city 2 to city 1 by stopping at city 3. But can y'all see that by reading these rows and column numbers here? Right. What if I asked you 2, 3, and 1, 3? Would that tell me anything? No, because I would literally figure out how many ways to get from 2 to 3, and then a totally different side would be 1 to 3. I can't teleport from 3 back to 1. All right. So make sure those inner ones are the same when you're doing your calculations yourself. The two, the inner numbers, they need to be to have a meaning. If they're not, they won't have a meaning. So typically, yes, they're going to be the same, because without it, it doesn't mean anything, because it's not realistic. Not possible or something. Or you could calculate the number, like say 2 times whatever, because that math is possible, but then it would mean nothing because there's no way. That's a good question. Any others? All right. Part 4 or question 4 says, write an expression for the total number of one-stop routes from city 4 to city 1 and determine the number of routes in one city. All right. So I want you to go from city 4 to city 1. So you got to stop at least once. So that means you go 4, 2, 1 or 4, 3, 1. Close.
Oh, wait.
Because you have to multiply. Right. So what you can do with the matrix is I'm going to rewrite the matrix one more time so that we have it so I can illustrate it for you. This was 1, 3, 1, 0, 2, 0, 2, 2, 2, 1, 0, 1, and 0, 2, 1, 0. All right. So I want to go from city 4 to city 1, stopping in one city. So that means I need to be able to go from 4 to 1, stop at 2, and 4 to 1, stop at 3. So let's see if we can illustrate that. So that would mean I need to know what row 4 to 2 is, I want to go from 4 to 1, but I want to stop at 2, times the element of 2 to 1. Because, again, I went from 4, I wanted to stop at 2, and then from 2, I wanted to go to 1. I need to figure out what that result is. How would I rewrite this next one? If I want to go from 4 to 1, but I want to stop at 3. Four to 3, perfect. Perfect. Now, once you have the equation written, now you just got to pull your numbers, multiply it out. So what is 4, 2? Perfect. So this would be row 4, column 2. The answer would be 2. What's 2, 1? 2. Row 2, column 1 was me at 2. 2 times 2 is 4. So there's 4 ways to go from city 4 to city 1 with at least stopping at city 2. All right. Again, I know we've done this math earlier by just looking at the diagram, but now we're trying to pull the same information from a matrix as well. All right. So what's 4, 3? All right. 4, 3 would be right here. So that is 1. 3, 1. 2. So that's row 3, column 1. Puts me right here at 2. What's 1 times 2? 2. And then we're going to add those results up. So 4 plus 2 gives me 6. Questions on how to use the matrix to find your answers? The big part is I need y'all to understand how to set these up. All right. So notice again the middle number, the inner numbers for each one. What's my stopping spot? And the first number is where I started, and the last number is where I want to end. All right. We're good with that? Does that make sense? Okay. All right, so I'm going to try to do 5 so I don't have to lose my matrix there. Do you notice any patterns in the expression for the total number of one-stop routes from city 4 and city 1? Okay. That's perfect. That's what you need to identify. The middle numbers need to be the same. In this example, this would be the one-stop city. Do it.
Siri.
Oh, I thought it sounded like a robot, but it sounded like a very strong, huh? Whose was that? Okay. All right. All right. So the middle, I forgot the E. Yeah, sorry. The middle numbers need to be the same. That would represent that one-stop city that you're stopping at. And I would even add these notes. The first number needs to be the city you start at. The last number needs to be the city you end at. All right, that's basically just in words what I just said on the conclusion number 4. Any questions there? All right, so what I want to go into now is I want to give you a random matrix and see if you can give me the bus route back. I'll do one with you and, of course, let you try one on your own. Any questions up to this point? Again, we haven't done much math. You're really just analyzing a matrix and analyzing a network. We good? All right. So again, what I want to do is I'm going to give you a matrix and we're going to write out a network. This part I like. I really like. It's like playing Sudoku. This stuff is just fun. or doing a puzzle. You like puzzles, this will be fun. I've gotten to that age where puzzles are fun. All right, so here we go. So we're going to create a network diagram from the matrix below. Each matrix represents the number of transportation routes that connect 4 cities. So again, this will be cities 1, 2, 3, 4 is where we start. This will be the en route cities 1, 2, 3, 4. The rows are the cities you travel from, and the columns are the cities you travel to. All right, so here we go. I know there's 4 cities, so I'm going to kind of map it however you want to design it. You can make it the 2 triangles. You could do this if you like. 1, 2, 3, 4. There's no specific correct right way of where you start your cities. If you want it to be super fancy and you want to put 1 here, 2 there, 3 there, and 4 there, by all means, you can do whatever you want. What's going to matter is where your arrows are. So this is again 1, 2, 3, 4. 1, 2, 3, 4. What's row 1, 1 represent? 0. What's it represent? There's no loops on city 1. There's no way to get from 1 to 1. So I don't have to draw anything. What's 1, 2 represent? 1 way to get to 2. So I'm going to draw. Let me do a different color. I'm going to draw 1 way to get to 2. So notice there's 1 way to the arrow. I don't know if there's going to be an arrow added to this yet, but I know there's 1 way to get to 2. We good so far? 1 to 3 means what? There's no routes there. 1 to 4. Just 1 way to 4. Good with that? So if you did the 2 triangle things, we would now have a arrow going across to the other side of it that we didn't have before. All right, 2 to 1. All right, so 2 to 1. Since I already have an arrow there, I'm just going to put an arrow going both directions. 2 to 0 means, sorry, 2 to 2. 0 means I have no loops, so there's no way to get to 2. What does 2 to 3 mean? 1. So 2 to 3, I have 1 route to get there. 2 to 4. 1. So I go from 2 to 4. 3 to 1. 1. So I have a route this way. All right, so I go from city 3 to city 1. 3 to 2. Since I already have the one there, I'm just going to add an arrow to the other side. 3 to 3, there's no loop. 3 to 4, no paths. 4 to 1, I already have a path, so I'm just going to add an arrow there. 4 to 2, again, I already have a path, so I'm just going to add an arrow there. 4 to 3, there's no way. 4 to 4, no way. So this is what we should have ended with. Questions on that? Make sense? Go ahead and try B. Create your own network with the matrix given. And I can't express this enough. It does not matter where you start 1, 2, 3, 4. It just means all about those arrows. We all think we have answers? Let's check it. So I see it helps to label it. More welcome to do that. I have no routes, no loops on 1. 1 route from 1 to 2. None to 3, none to 4. From 2, I got none to 1. I do have a loop on 2. And then 2 to 3. If you want to do a different color, that would have been fine there. But there's 2 routes to get there. And then 2 to 4. 3 to 1. None from 3 to 2. None from 3 to 3. And then 2 from 3 to 4. 4 to 1, there's none. 4 to 2, there's 1. So I'm just going to add an arrow. 4 to 3, there's 2. So I'm going to add an arrow on both of those. And then none, therefore. Should all produce something like that? So again, notice I didn't have to make a square. I can make a triangle just like in the previous figures. That part doesn't matter. The arrows are the only thing that's going to be your real grade. Bless you. So we're good with that? You asked, does it ever get more complicated than that earlier in the lecture, didn't you?
Yes, sir.
Let's look at the next example. Huh? What? 1 minute? I'm going to be honest with you. I would have kept on going. However, let's look at that next problem, and then you tell me you think we have enough for it. It's just a bus route, but it's showing you it's a run direct. So 1, and I think it's talking about friends, but we'll get to this tomorrow. 1 to 3, 1 to 4, 1 to 5. So this friend can get is friends with these 2 friends. And then 2 is friends with 7. 3 is friends also with 5, 6, and 7, but also still friends with 1. So that's kind of what this is. It's a friend change. Yeah. So basically, you're just trying to figure out if I want to tell 7 something, who do I need to talk to get 7 a message, No, 1's not friends with 7. Oh, it is. I see it on the bottom. Yes, but 1 does not friends with 2. I don't think 1 could get a message to. No, 1 would have to talk to 7, and then 7 would have to go talk to 2. But we'll talk about that tomorrow. You enjoy the rest of the day, guys.